Alright, now we're going to determine the mode shape. So what does mode shape tells us? The mode shape tells us the motion of each masses as another mass is moved relative to the other. So in order for us to determine the mode shape, so first we need to recall back this matrix. Okay, so what does mode shape is? Mode shape is actually derived from this thing, the A1 and A2. So mode shape is actually from here, it's A1 over A1 and A2 over A1, meaning that mode shape is from here relative to A1. So this will become 1 and this will become A2 over A1, or sometimes we write it as R. Okay. So in order for us to identify the mode shape, we can use either the first row or second row. So let's say I want to use the first row. So from the first row, 35 minus 10 omega squared so this is A1 over A1, A2 over A1, so 1 and R. A1, so this multiplied by this, sorry, this is actually 1, minus 5, which is this one, multiply with R. Is equals to 0. So in here, by using, so if we want to find the first mode shape, so for the first mode shape, so we use omega 1 squared equals to 2.5, where omega 1 squared is equals to 2.5. So we replace this value in here. So 35 minus 10 multiply with 2.5 minus 5 R is equals to 0. So $35 minus 25 is actually 5R. So R is equals to 2, meaning that the first mode shape which is 1 R, okay, this is 1 and R, it's actually 1, 2. So this is the first mode shape. So if I draw the mode shape diagram, okay, so This is the amplitude. So 1 and 2. So the first mode shape starts from 1, so from 0 to 1. Okay, so this is A1 and it goes to 2. So this is A2 and there's a here. So this is the first mode shape diagram. Okay, so 1 is here and 2 is here. Alright, so for second mode shape, okay, so for second mode shape, we need to use the second natural frequencies value, where omega 2, because we want to do the second mode shape, so we need to use omega 2, but we use omega 2 squared instead of omega 2. Why? Because in here it is given as omega squared. Okay, so it's easier for us to use omega squared value. So for second mode shape, we use this value. Omega 2 squared equals to 6. So we write back this equation. As I mentioned, you can use the first row or you can use the second row. So I'll just stick to the first row. Okay, but the value in here is not 2.5 anymore. It is 6. Okay, 35 minus 10 multiplied by 6 minus 5r is equals to 0. So solve this. Negative 25 is equals to 5r. So r is equals to negative 5. Okay, so what I did was, same thing. I just used the first row equation. Okay, call back and then replace the omega squared value. So the second mode shape, you write as x2 is actually 1 r or 1 negative 5. Okay, so the mode shape diagram, okay, same again. We draw 1 first here, and the second one is negative 5, so it's somewhere around here, negative 5. So first draw A1. So this is A1, and then for A2 it goes down to negative 5. So this is A2, and then we close back in here. So this is the mode shape diagram. So for the first mode shape, what we obtain is 1, 2. So meaning that what it tells us is that if we look back in here, it's 1, 2. The mode shape is 1, 2. So meaning that what it tells us is that if mass 1 is moving to the right hand side by 1 unit, okay, so the second mass is moving to the right hand side by 2 units. So that is what it means by 1, 2, meaning that 1 is for mass 1 and this 2 is for mass 2. So why both moving on the same direction is because the sign here is both is the same, or in here it shows positive. So meaning that if mass 1 is moving to the right hand side by 1 unit, mass 2 is moving to the right hand side also by 2 unit. So in here, if I want to explain more, so if mass 1 move to the right by 1 unit, mass 2 move to the right by 2 unit. Okay, 1, 1 and 2, 2. Okay, so how about the second mode shape? So second mode shape, we got 1 and -5, meaning that if mass 1 move to the right by 1 unit, okay, 1 unit, mass 2 move to the opposite direction, which is left opposite direction. Why? Because we got -5 here by 5 unit. So this is the explanation of mode shape. So I think that's all for this example. So I'll see you guys in the next lecture. Thank you.